Hello everyone, welcome to the Seaborn series. In this video, we will be discussing the violin plot in details. Violin plots are used to find the relationship between the numerical column with respect to a categorical column. So let's first draw a simple violin plot. Please find the below code. Let me draw it for you. So now we can see this is the simple violin plot. So when we look at this figure, there are three things which we can see. The first thing is the middle line. So this middle line is basically representing the median of the data, which is median here represents the middle value of the data. The width of the volume, you see here, this is the width, this horizontal part. Okay. So this shows how many data points fall in that particular range. If the violin is wider at a certain height, let's say it is wider at this particular height, which means we are having more values in this particular range. Okay. So the wider the volume violin plot it at a particular certain height, it means that there are more data points at that particular height. If it's narrower, you see here at this particular height it's being narrow, which means that there are fewer data points. And then the overall shape of the data. So when you look at the overall shape of the data, if the shape of the data basically represents the distribution of the data, if the shape of the data is wider, which means that there are more data points, and if it is being narrower, then there are fewer data points. So in this way, we can also do a kind of a comparison. Like let's say we have fuel type gas and diesel. Okay, so and we have the city MPG. So we can say here is like the range of value. You see here the for the diesel it's starting from here, but for the gas it's starting from here. So we can say that the diesel range is much starts at a much higher value. Okay, the other thing is we can say that the width of the gas is much more higher at here. So you can say that there are more values between this particular range, whereas the width of this particular where the fuel type is diesel is much more less as compared to the gas. Okay, so this way we can do a kind of a comparative study. We can say that the shape of the gas is much more higher as compared to the shape of the diesel here. So there are more data points with where the fuel type is gas, which means in our data set there are more cars with fuel type as gas and having a city mileage. Okay, but even if there are fewer cars with diesel, they have a higher CT mileage. You can see it's going a little bit higher, but this is much more higher. There are certain points which is going much more above the this 60 mark, or you can say the 55 mark. Okay, so this one we can do the comparison. But in a simple words, that there are three things which you have to look into it: the middle line, which is the basically the median of the data, the width of the violin, and then the overall shape of the violin plot. Okay, so now we are going to draw the quartiles as a horizontal line, because right now in the middle line it's being showing the density, or it's showing the middle line, median of the data. Okay, so how we can do that? We can in the inner parameter we will just put it as quartile. So here you can see the inner parameter is being put as quartile. So what will happen here is, so it's going to create the interquartile. Okay, so this is the first quartile, second quartile, third quartile, and similar way for diesel also, first quartile, second quartile, and third quartile. Okay, so whenever we set the inner is equal to quartile in a violin plot, you can see here. Okay, Seaborn will add lines inside the violin plot. Okay, to mark the first quartile, as we said, the median, which is this is the middle value, the 50th percentile, and the third quartile, which is the 75th percentile. So the first quartile is the value below which the 25% of the data falls. So below this line, or below this line, 25% of the data falls. Okay, and then we have this median value where below which the 50% of the data line, which is the basically the middle part. This is the middle part. And then we have the 75% of the third quartile, which is this particular line, the topmost line. Okay, so this is representing that the values below this is 75% of the data falls. Okay, so the value below falls under the 75% of data falls below this particular line. Okay, so it represents basically the upper bound of the middle 50% of your data. Okay, so this way we can find it out that how are the quartile range. So we can also put the quartile range here by using inner is equal to quartile. Now, the next thing is like how we can remove the interior. So if you want to remove this interior, you don't want to show anything inside your violin plot. So then what you can do, you can just simply You can put inner is equal to none. So let me show you. So if I draw this, so if I do it as inner is equal to none, then it is going to represent like this. So you can see there's nothing representing. There's no median line. There is no interquartile. There is no dotted points. Nothing is there. It's completely blank. So you can do this by inner is equal to none. Next thing is how we can plot the horizontal violin plot. So here you can see that when we are drawing this violin plot, in our x-axis we have the numerical column. We have the categorical column in the x-axis, and on the y-axis we have the CTMPG. If we want to draw a kind of a horizontal violin plot, what we have to do? We have to reverse the assignment of the axis to the columns. So in this case, what will happen? We have to put the numerical column on the x-axis and the categorical column on the y-axis. So I can give you an example. Let's see with this example. So here what we have done, we have put on the y-axis, we have put the categorical value, and on the x-axis, we have put the numerical column. Now let me run this. So you can see here, we have plotted the horizontal, um, horizontal violin plot. Now we can also use hue here to show the relationship with another categorical column. So we can do this by putting the parameter hue is equal to the column name. So here we are using hue is equal to fuel type. Okay, and we are finding the relationship with body style and CTMPG where hue is the fuel type. So let me run this code. So this is going to give us the value of the relationship between the CTMPG and body style with respect to the fuel type. So you can see here fuel type, they are separate um, separate box plots which is being sorry, not box plots, separate violin plots are being created with respect to fuel type. So we can say here when the body style of the car is convertible and the city mileage is also on the x-axis, so there are uh, no cars which uses the fuel type as diesel because there's no blue point here. So similar for the hatchback. So we can say that when the fuel type is convertible and hatchback, there are no cars which uses the fuel type as diesel. Okay. Similar way we can for same for the hard top, and that way how we can do the analysis in detail. So it's more kind of an example of a multivariate analysis where more than two features or columns are being involved. Next is split is equal to true. So when we say split is equal to true parameter, it is being used when we are plotting a violin plot with a hue variable. So as we have seen in the previous example, when split is equal to true, the violin plot will split the violins to show the distribution of the hue variable side by side within the same category. So let's see with this particular example. So here we have used the same code as above, but here we have used split is equal to true. So now we can see that our diagram is being split into two parts. You can see it like this way. So this is how we can do with the help of the split is equal to true. We can also draw multiple violin plots using the subplot function. So here we have to use, let me show you with the code. So here what we are doing, we are trying to plot the different violin plots, keeping the numerical column same, body style. And here we have the y is being sorry, we are keeping the categorical column same and the numerical column is being changed. So we are plotting the body style with respect to the CTMPG, wheelbase, length, and width respectively. So now let me run this code and we can see all the diagram is being run. So here we are making the total number of diagrams as 4 plots. So you can see here 2 rows and 2 columns are being defined, and they have been mentioned the position also. So this way we can plot the plot the multiple violin plot using the subplot function. Next is Facet. So here we are going to use cat plot. So the interesting thing about cat plot is like we can we can, as we have seen earlier also, with the help of the cat plot we have drawn the strip plot. So similar way, with the help of the cat plot we can also draw we can also draw the violin plot. So just you have to change the parameter. So if you change here kind is equal to violin, it's going to create the violin plot. And one more thing here is like we are going to use the col parameter. Col parameter is equal to fuel type. So what will happen here is when I run this code, a separate diagram will be drawn. Instead of using hue in hue, what was happening that one diagram both both the fuel types it was being drawn. See here, fuel type, gas and diesel, both of the diagrams were shown. okay, for fuel type. But when we use it as a facet, and when we use col is equal to fuel type, so let's say here we have fuel type, two types, gas and diesel. So for gas there will be a separate diagram, okay, showing the relationship between body style and engine style. And for fuel type is equal to diesel, there will be a separate diagram. So this way we can plot the violin plots. These were some of the few examples which I have mentioned. For more detailed view, you can always go through the official website of Seaborn Violinplot, and you can see how, in how different ways it can be drawn, how in different ways, what are the different parameters of doing it. I hope you find this video informative. Please subscribe to my channel. Thanks.